Alright, so let's take a look at our little worksheet here that's got a few extra tangent problems on it. So let's take a look at this. And then talk a little bit about okay. So portion of the tangent, okay. What is the period of the picture drawn there? What is the period of that function? Too high. Period for a tangent is asymptote to asymptote. This one is 2 pi. What is the normal period of a tangent? Pi. Yeah. Okay. Number 2. So we got this equation. What is the period of h? I don't know, I just have this thing. I like to have my vertical shift out here. So I've rewritten it this way. What is the period of this thing? Pi over 4. Thank you. Okay, if you did not carefully watch the e-learning video, which I don't think some of you did, you better, because we don't have time to go back and redo that lesson. That was your lesson for the day. You need to know that stuff. The period of the tangent is pi. There's a 4 right there in the B spot. What does that do? It divides the period. Pi divided by 4. Now, doesn't say to, but I want to get a graph in, so I'm going to graph this one. First thing I notice is I have a vertical shift of 7. So what does that do? That lifts up my axis. Now it's up here at 7. I notice that there is no horizontal shift, no phase shift to this problem. So that means nothing has been shifted left and right. So the dot in a normal tangent curve, the dot is at the origin, and that has not moved. That is your normal tangent right there. I haven't moved it. I've done other things to it, but I haven't slid it sideways. So that dot's gonna stay right there. On either side of that dot, there is an asymptote. Now you told me that the period of this thing is pi over 4. That does not mean this is pi over 4. If the period is pi over 4, then this distance is pi over 4. Asymptote to asymptote. Which means, what's this label? Pi over 8. And this one's negative pi over 8. Right? Now, I have done a couple of things. I've turned my curve upside down. So instead of starting down here and squiggling up, it's going to start up here and squiggle down. Would you agree with that? I have also multiplied it by 3. Now remember, in a normal tangent curve, because of the whole pi over 4 thing, think of your pi over 4 angles. X and Y are the same. Tangent's 1. That's normal. Well, normally then, halfway in between my dot and my asymptote, I should be up 1. That would be the normal place. But what have I done? I've now times it by 3 and turned it upside down. So now that dot is coming down 3 and over here going up 3. So the curve is steeper, less curvy than it would be under normal circumstances. Now, this point right here on the translated axis, that point right there, is where we change. That's the point of inflection. We change from being concave up to being concave down. That point is where your concavity changes in the tangent. Okay, all right, number 3, what's the period of this one? 3 pi. Why is it 3 pi? Because it's pi divided by a third. The standard period of a tangent is pi. Start with pi and then divide it by a third. All right, what about this one, number 4? What's your period? 1. And number 5, what's your period? It'll be pi divided by pi over 4, right? Which is pi times 4 over pi. So what's your period? 4. All right, let's look at the next one. So this is tan 2 theta. No shifts, right? So we got an we got a dot right there at the origin, 0 right at the origin. We have an asymptote over here and an asymptote over here, and they're period apart. What is the period? Pi over 2. So this is 1/4 and negative 1/4. Those are where your asymptotes are. Where is your beginning asymptotes? Where is your next asymptote? Well, remember, asymptotes are a period apart. What did you say the period was? Pi over 2. So won't we find this one by adding pi over 2 to pi over 4? Yeah. And isn't that how we would find the next one and the next one? So which of these expressions describes that? C, because it starts with pi over 4 and it adds multiples of pi over 2. All right, which of the following, okay, same question. This one's a little bit trickier though, because what's happened in number 7? We've shifted. All right, pay close attention, guys. We've shifted. So now we are sketching that. Now what does that mean? That means that what used to happen at the origin now happens at pi over 2. So that 0 that happens at the origin in a regular tangent moved. Just like with the sine, when you move to hills and valleys, we're moving our 0. And it's moving to here. Now, on either side of that, there's going to be an asymptote. What's the period of this guy? Pi? So where are the asymptotes going to be? They're going to be half a pi this way and half a pi this way. Would you agree with that? Now, where will the next one be? If the period is pi, then won't I just add pi to this? And so on? All right, so which of those things describes what's happening? See? 0 pi, 1 pi, 2 pi, 3 pi. Starting at 0 and adding pi, so it's C. Okay, 8. The graph of the function, if this is this, which of the following are true? Well, first of all, can you tell the thing's upside down? A normal tangent is increasing on its entire domain. Tangents go up. This one's going down, so it is, A has to be negative, right? So A is less than 0, which automatically means I'm either at C or D. Would you agree with that? Now, what's the period of the picture drawn? Pi over 2. So I'm trying to figure out what B is. If period is pi divided by B, then doesn't my B have to be 2? Which means it's bigger than 1, so the answer is C. Right, you've already done a bunch like those, let's skip those. Number 9. Tell me what you think. Now, things can get confusing here for sure, but pay attention to the format of his equation. It's tan B x plus C. Okay? Now, tell me about the period of the picture he drew. The period of the picture he drew is 2 pi. So period equals pi over B. So it looks like B has to be 1/2. Everybody good on that? All right, and then I need C. In a tangent curve, 0 is that dot right there, that x-intercept. Where is that x-intercept in the problem that he drew? At pi? So you have moved your picture pi? So what do I put here? It went pi to the right. So what is my C? What would be in the parentheses here? X minus pi? So what's your C value then? Negative pi? Now it doesn't mean your phase shift is negative pi, it means your C value is negative pi. So which one matches all that? Do I have one that does that? B? Problem B? Or answer B? All right, number 10. Can you find the right equation for number 10? It can't be D. Someone tell me why it can't be D. Yeah, the dot's right where it's supposed to be, right? There's no phase shift. Okay, so it's not D. Okay. It's not A. Why is it not A? It's not upside down, yeah. Okay, so what's a period? Pi over 2, which means B has to be 2. So the answer is C. In the xy plane, an angle theta is in standard position with a measure of 5 pi over 2. Which of the following is true? Remember that slope and tangent are the same. So if you're at if you're at 5 pi over 4, which is right here, what's your tangent? Positive 1. So the slope is positive 1, so the answer is D. Tangent, y over x. Slope, y over x. Same thing. The slope of the terminal ray is -1. Which of the following could be the angle theta? So the tangent is -1. C. Now, there would be other answers, but in this set, C is the only one that would work. Okay, in 15, the slope is undefined. C, yeah, 3 pi over 2, the top and bottom of the slope. Very, very good. All right, I want that 3.8 homework done on Thursday. And I need you to get your notes out and turn to page 9. We're mixing it up a little bit, but turn to page 9. Okay, so we're on page 9. Okay. Evaluate, here we go, sine 7 pi over 6. Negative 1/2. Negative 1/2. Right, guys, people? Okay. Sine negative pi over 6. Now remember, negative angle means you go this way. So it's the pi over 6 in quadrant 4. So what would that sine be? Negative 1/2. Sine 11 pi over 6. Negative 1/2. Because isn't that coterminal with negative pi over 6, same place? And what about 19 pi over 6? Okay, so remember, 19, that would be 3 1/6 and pi. And I can take out 2 of those. So isn't this the same as, and I'm using that loosely, it's not really the same as, but isn't it coterminal with 7 pi over 6? And what's the sign of 7 pi over 6? Negative 1/2. What this exercise is trying to get you to understand is problem number 3. How many solutions are there when we say the sine of the angle is negative 1/2? How many answers are there? Infinitely many. Some in quadrant 3, some in quadrant 4, but there are infinitely many of them. So, when it comes time to answer that question, which, what does that little negative 1 always mean? The inverse. So we are now working it backwards. Here, they gave you an angle and you produced a sine value. So when we said 7 pi over 6, you said negative 1/2. Well, what does the inverse do? The inverse gives you the sine value and then you come up with the angle. Well, we just talked about it. What's the problem with this? The problem is, how many possible angles could you come up with? Infinitely many. And that's too indefinite for a mathematician. A mathematician wants an answer. Okay? So we're going to figure out how we're going to consider just one answer instead of infinitely many. Okay, so here's what we're going to do. Let's look. I'm looking at problem 4 now. I haven't answered this one yet, but we're going to answer it in a minute. Here is my sine function. We know it goes on forever and ever. We know this is pi over 2. Okay, so we know this. Is this function 1 to 1? No. What does 1 to 1 mean? 1 to 1 means that every X is used once and every Y is used once, okay? You don't need anything repeated. In other words, it passes the vertical line test, which it does, but it also has to pass the horizontal line test, which it doesn't. When we said let the sign be -1/2, how many answers did we get, guys? Infinitely many, because -1/2 crosses the sine curve in infinitely many places. So what we do is restrict the domain. So instead of considering the whole shebang, we are only going to consider this much of the curve. Look at the blue. Is the blue 1-to-1? Does it pass the vertical line test and the horizontal line test? So when we answer an inverse sine question, this problem literally says, tell me what angle has a sine of -1/2. And we know there are infinitely many of them. You have to pick the one that is between -π/2 and +π/2. So think about all of the angles that have a sine of -1/2 on your circle. They're in this part of the circle, -π/2 to π/2, right, over here. What angle would have a sine of -1/2? Well, it would have to be down here, right? And for pi, that angle is π/6. So what angle is that? Be careful. -π/6. Because any answer you give me has to be in that interval. Inverse sine, also called arc sine, is only defined here. So if you answer with something like 11π/6, I agree with you 100%. That angle could also be named 11π/6, but not in an arc sine problem. In an arc sine problem, it must be -π/6. Okay? Yeah, Josie?
Does it matter, like, what section of the graph you
Yes.
use to restrict the domain?
Yes, it does. We don't get to make those rules. Now, mathematically speaking, could we have picked a different section, totally and completely, but the guys who put all this together didn't. So when they programmed your calculator, anytime you press this button, the answer is going to come out in this interval. And so that's just generally accepted as the interval we use for inverse sine. All right? Now, let's take a look at, I'm veering away from the notes here a little bit. Let's take a look at cosine. Should we use the same interval for cosine? If we use the same interval, -π/2 to π/2, that would be this chunk of the cosine curve. Is that red thing 1-to-1? No, so that won't work. Can't use that section for a cosine. How about if we use this section? Would the blue section work for the cosine? Yep, and that's how it's defined. So for arc cosine, which is the same as inverse cosine, whichever way you want to write it, be comfortable with both. They mean the same thing, you need to know that. your domain, your interval of accepted answers is 0 to pi. So, let me give you a problem here. Suppose I said, find the angle whose cosine is negative root 2 over 2. Now keep in mind, you turn this part of the circle, 0 to pi for cosine. If that's a negative number, which have to be over here, and you recognize that, that's which angle? Pi over 4? So how are you going to answer the question? 3 pi. These are called the principal values. The principal values for the inverse cosine are 0 to pi. The principal values for the inverse sine are negative pi over 2 to positive pi over 2. So what about tangent? Here's my normal tangent curve. Now remember, there's more of those, right? There's more of those. But if I look at just that one right there, is that good? Is that 1 to 1? Yeah. So the principal values of the tangent are the same as for the sine. Inverse tangent has principal values, well actually I can't include those for the tangent, from negative pi over 2 to pi over 2. So any inverse tangent problem you do, using that notation, so if it says, find the angle whose tangent is 1. Well, how many of those are there? In reality, infinitely many, but within our constraints, there's only one. There's one answer. And what would the answer be to this problem? The tangent is 1. Pi over 4. The answer is pi over 4. This means find the angle whose tangent is 1. Find the angle, the one angle whose tangent is 1. All right, let's look at the back side of the page. Okay, so now you have your principal values, you have your rules. So now we're ready to get into these. Arc sine negative root 2 over 2. One answer. Your inverse problems have one answer, period. So what is it? Arc sine negative.
Negative pi over 4.
Bingo. Negative pi over 4. I'm not sure what all went through Oscar's mind, but remember, arc sine is only defined over here between negative pi over 2 and pi over 2. That's it. If it's a negative sign, it's down here. If it's root 2 over 2, then you know it's a 40 or pi over 4 angle, right? You're not allowed to say 7 pi over 4. You have to keep it within this interval, so it has to be negative pi over 4. Beautiful, Oscar, beautiful. How about the next one? The angle angle whose tangent is negative root 3 over 3, which remember is the same as 1 over negative root 3, right? Just rationalize. Inverse tangent, same side of the circle. Negative pi over 2 to pi over 2. Those are the rules, which you're going to memorize. If it's negative, it's got to be down here. Let's see, I don't think it's there, I think it's here. Wouldn't that be pi over 6? And that would be negative pi over 6, because you're coming down. Arc cosine 3 pi. Now, a little tricky for day 1 on this topic, but remember, this notation literally says, find the angle whose cosine is 3 pi. That's what the problem says. Find the angle. What's the decimal value for 3 pi? 9 point something, right? Can a cosine be 9? What's the highest a cosine can go? Unless you multiply it by something. What's a regular cosine? What's the highest it can go? 1? Can cosine be 9? Get your calculator out. Type this on the calculator and tell me what happens. Your cosine uses, or your cosine, your calculator uses this notation, means the same as that. What's it say? Error. Cosines can't be 9. Whatever this number is, it has to be less than 1. So, would you note the directions say, explain why it's not possible? That problem isn't possible because you cannot have a cosine that's bigger than 1. Number 2, now we're going to find out if you have been paying attention or not. Determine if each statement is true or false for the reason for your answer. Number A, letter A. Literally says, find the angle, that's what this says right here, find the angle whose sine is the sine of 5 pi over 6. Okay, so what's the sine of 5 pi over 6? What's this right here? Negative. Oh no, that would be positive, wouldn't it? The sine of 5 pi over 6 isn't that positive 1/2? So this says find the angle whose sine is 1/2. What is the angle whose sine is 1/2? Now remember, sine is restricted to here. What is the angle whose sine is 1/2? Pi over 6. So this is false. Why is it false? Because when you use this notation, your answer has to be basically in quadrant 1 or 4, and that angle is in quadrant 2. Craziness. All right, what does the next one say? The cosine of the angle whose cosine is negative root 2 over 2 is negative root 2 over 2. All right, let's figure this out. The angle whose cosine is negative root 2 over 2. Which quadrants is inverse cosine? 1 and 2, right? 0 to pi. What is the angle? This is asking you for an angle. If the cosine's negative, then I'm over here. So what would this be? 3 pi over 4. Perfect. Now, what's the cosine of 3 pi over 4? Negative root 2 over 2. So that one is a true statement? True statement. All right, so I think I'm going to skip the rest of those, and let's go to the notes now for this section, the regular Mr. Passwater's notes. Which, for some reason, I'm going to blame it on being 65. I copied the same page twice. So let's just go to page 7. Page 8 is exactly the same, so you can look on page 8 if you prefer. Sorry about that. And actually, we can go to the back of that and look at example 2. Example 2. Take a second and see if you can evaluate these. Having had the discussion that we just had, having kind of the key at the top of the page there with the halves of the circles denoted, see if you can answer example 2. Quickly, we don't have much time. Remembering that number A, for example, says, find the angle whose cosine is negative root 2 over 2. The answer to each of these is an angle. Did this first one. All right, we just did A. Did you come up with the same answer we did before? What'd you get? 3 pi over 4? Perfect, it's over here. 3 pi over 4. How about sine, the angle whose sine is negative root 3 over 2? It's down here, right? What did you say? Negative pi over 3. Beautiful. Negative pi over 3. And in this one, there's nothing special about it, but I need you to get used to seeing this notation and immediately thinking, find the angle. This is find the angle, whose tangent is root 3, which would be up here. Did you say pi over 3? perfect. All right, example 3 and yeah, example 3, here we go. The angle theta is in standard position. The terminal ray intersects the unit circle, so this is a unit circle, at xy. So the coordinates of P are positive x, positive y. So the cosine at P is x, and the sine at P is y. Okay? So now look at problem A. What angle, what point is on the terminal side of the angle whose cosine is x? P? That's point P. Isn't the cosine x that point P? All right, where is the sine negative y? S. S. And some of you are thinking, well, it's negative y at r also. And you're right, but remember the rules. For inverse sine, you are restricted to this side of the circle. So you can only be looking at points on this side of the circle if it's an inverse sine problem. All right, where is the cosine negative x?
Q.
Point Q, absolutely, because you're up here. Yep. And where is the tangent negative? It's down here, which is S. Yep, S. Got it? Okay. One more thing. Grab this real quick. We haven't done one of these in a while, but you remember doing a thing called 5 for 5 at one point in another unit? This is 5 questions getting increasingly difficult. And the idea is if you can get all 5 of them, then you're on your way to a 5 on the exam. So we're going to try. We probably aren't going to get all these done, but we'll get as many of them done as we can, and we'll finish up tomorrow. All right, take a minute, everybody do, well, just get started. We're going to kind of check number 1 here in a second. But just get started. See if you can answer number 1. Find the angle whose sine is negative 1/2. Think about your circle and where you are looking for the angle whose sine is negative 1/2. Anybody want to give an answer to that one? A, perfect, beautiful. Hopefully y'all got A. Okay, all right, same thing, move on, number 2. We got that one. The angle whose tangent is 1. B, pi over 4. Okay, perfect, 2 for 2, awesome. Okay, spend a minute with number 3. Shoot, I never took attendance. Just like in all mathematics, I hope you kind of started in the parentheses. What's the sine of 5 pi over 3? Negative root 3 over 2. Are we in agreement with that? So the question says, find the angle whose cosine is negative root 3 over 2. Well, where are you going to look? It's a cosine, so you're going to look over here, cosine's restricted to 0 to pi, so you're over here, inverse cosine. So if a cosine is root 3 over 2, then the angle must be pi over 6. And if you're in quadrant 2, pi over 6, that would be 5 pi over 6. Did anybody get that all by yourself? Yes, good, good. Now, if you didn't get it, do you follow the steps we just took there to figure that out? All right, number 4. Can anybody read that problem to me? What does that say? Find the, I heard somebody say it, find the tangent of what? The angle whose tangent find the tangent of the angle whose tangent is 2 pi over 3. Find the tangent of the angle whose tangent is 2 pi over 3. Who's buried in Grant's tomb? What's the answer? 2 pi over 3. Find the tangent. Okay, so think about it. There's an angle out there. There's an angle out there, and all we know about this angle is his tangent is 2 pi over 3. Oh, I know what's confusing some of you. You're thinking you can't have that bigger than 1. For a tangent, you can. What does a tangent look like, guys? Do tangents get real big? Yeah, there's no size restriction on a tangent. There's no size restriction on a tangent. This is a decimal number. I don't know, what is that? 2? Roughly 2? So there's some angle out there that has a tangent of 2. It's right there. What's the tangent of that angle? 2? Yeah, the answer to this is 2 pi over 3. I want you to think about that. Say it to yourself. I got an angle whose tangent is 2 pi over 3. What's its tangent? All right, we'll do the last one tomorrow. Think about that. Maybe do it on your own. Think about that. And if you didn't carefully watch the 3/8 video and fill in your